Welcome to Practical Cardiology Pearls, where complex cardiology is simplified.
In this video, we'll talk about creatinine, eGFR, and cystatin C. I'll try to explain what each of them means, how they differ from one another, and why looking at creatinine alone is often not enough.
Let's start with creatine. Creatine is a naturally occurring compound that's made mainly in the liver and to a smaller extent in the kidneys and pancreas. After it reaches the muscles, it's converted into phosphocreatine by the enzyme creatine kinase. Phosphocreatine acts like an energy storage system, providing a quick source of energy whenever the muscles need it. When the muscles need energy, phosphocreatine is broken down to provide a rapid source of energy. As a result, creatinine is produced as a waste product. Creatinine then enters the bloodstream and is removed from the body by the kidneys. So, the more muscle mass a person has, the more creatinine they produce. People who are more physically active also tend to produce more creatinine. And a high-protein diet can increase creatinine production as well. On the other hand, patients with sarcopenia produce less creatinine. The same is true for people with low physical activity. But here's something interesting. Sometimes, when we measure blood creatinine, both patients have exactly the same creatinine level. How is that possible?
But there is one important point we should not forget. The blood creatinine level is determined not only by how much creatinine is produced, but also by how quickly the kidneys filter and remove it from the blood. This filtering capacity is called the glomerular filtration rate, GFR. For example, one patient may produce more creatinine but have normal kidney function. Another patient may produce less creatinine, but their kidney filtration is reduced. As a result, both patients can have the same or even a normal blood creatinine level. So, how do we calculate the glomerular filtration rate? We enter the patient's age, sex, and serum creatinine into an AI tool and ask it to calculate the eGFR. It provides an estimate of the kidney's filtration rate. This estimated value is called eGFR, or estimated glomerular filtration rate. At first glance, these results may make us think that the patient's kidney function is completely normal. However, when we calculate the eGFR, we see that the glomerular filtration rate is reduced. According to the KDI-GO-GFR classification, this patient falls into the G2 category, which indicates mildly reduced kidney function. Now let's talk about cystatin C. Cystatin C is a small protein produced by all nucleated cells in the body. Because it is cleared by the kidneys, it is considered a reliable biomarker for estimating the glomerular filtration rate, GFR.
Now let's compare cystatin C and creatinine.
Cystatin C is produced by all nucleated cells, but creatinine is the end product of creatine metabolism in muscles. Both are freely filtered by the glomerulus. However, cystatin C is largely independent of muscle mass, age, and sex. In contrast, creatinine depends on muscle mass, age, and sex. To estimate GFR, we have three equations. 1. eGFRcr, based on serum creatinine. 2. eGFRcys, based on cystatin C. 3. eGFRcr-cys, based on both serum creatinine and cystatin C. We simply ask an AI tool like this: 47-year-old female, creatinine 1.1, cystatin C 1.2. Calculate eGFRcr-cys, and it will calculate it in seconds.
Now let's see what the 2026 AHA Cardio-Kidney-Metabolic Syndrome Guideline says. One important message is that creatinine alone is no longer enough. If cystatin C is available, combining it with creatinine gives us a more accurate estimate of kidney function. If there's anything I missed, don't forget to share it in the comments below. Thanks for watching. Let me know in the comments which cardiology topic you'd like to see next. If you enjoyed this video, please like, subscribe and share. See you in the next video.